I really like this question. We've got a student forming regular polygon shapes using 1k ohm resistors. What is the maximum resistance between any two vertices? Vertices are corners. Okay, so if you're wondering, vertice is a corner or a place where they join of a square. So a square, part 1, that would be where you have a 1k, in with a 1k, in with a 1k, in with a 1k. So between any, this is the maximum resistance between any two vertices. We could test this out just to, since they're all 1k, I'm not going to write them all in, but you've only got two options really. You can measure the resistance between here and here, so between say point A and point B, or you can measure resistance between point A and point C, because any other combination is just going to be a variation of those two. So between A and B, if we're doing A and B, we've got, they're all 1k, so 1 over 1 in parallel with, we've got 3 ohms, so this is between A and B, so this is 1k in parallel with 1 plus 1 plus 1 is 3, so that is 1 over 3 equals 1 over that total resistance in parallel. So that's going to be 3 over 3 is an equivalent resistance, so we'll end up with 4 over 3, which means we go to 3 over 4 equals Rp, okay, 0.75 ohms. Now if we consider this time between A and C, between A and C, we've got 1 over 2 plus 1 over 2, because 2 1 ohm, 1k ohm, this is k ohms I should say as well, but that's sort of irrelevant, we're just trying to get the main idea here. And notice any patterns that we're going on. This would be a good scholarship question I think actually, but in any case, this is 1 over the resistance in parallel, which is 1 is 2 over 2, which leads to 2 over 2 is the inverse, so there's no real change there, which gives us 1 ohm, or 1k ohm is the resistance in parallel. So that's larger than 0.75, so between the two opposite corners gives us the maximum resistance in this case. Okay, and now this is kind of leading you on a little bit. Next you'll do a hexagon, and you're going to find that it's, I'm looking ahead here, but we'll go through and we'll test it. We're finding a kind of a general rule by increasing the pattern from square to hexagon to dodecagon. So let's just do it for a hexagon, and we'll see what we end up with, because it makes it a bit clearer about what you're doing. So a hexagon is 6-sided. There's 1, 2, 3, 4, 5, oops, I'm playing with the fonts by accident, 6. It kind of doesn't matter if you draw it terribly or not, but now we've got the options of A, and between A and B, and then between A and C, between A and D, and then all the rest will start repeating. So again there's still 1, 1, 1, 1, 1 and 1, and if we try this out, we'll do this in 4 and see what we get, because the pattern will emerge. So between A and B we've got a 1k, 1 over 1, in parallel with 5 other, so it's 1 over 5. And that equals, because this is equivalent to 5 over 5, that equals 6 over 5. So that means 5 over 6 equals our resistance in parallel, 5/6 of an ohm. If we do it between A and C, so between A and C, we've got 1 over 2 plus 1 over 4, and this is k, remember, equals 1 over the resistance in parallel, and 1 over 2 in terms of 1 over 4 is 2 over 4, so that gives us 3 over 4, which means 4 over 3, 4/3 is our resistance in parallel, which is 1.3 recurring. Okay, then taking the extreme case between A and D, we've got, it's A and D, not triangle D, we've got 1 over 3 plus 1 over 3, which equals 2/3, which leads us to have 3 over 2, which is 1.5 ohms for RP, or 1.5 k ohms. So again, same pattern, the extreme opposite gives us the maximum resistance. Okay, there is a pattern emerging here. If we wanted to, we could draw it out completely for the dodecagon, but you can look at this pattern and see that you're always going to get, where are we? You're always going to get 1 over, in the first one, let's do this for the n case, just because we want to try and make this kind of cool. So for n, to the general case, you're always going to have 1 over 1 plus 1 over n minus 1. Okay, because there's always going to be, if we go to our first, we'll just use this example above, there's 6, n equals 6, and you're always going to have 1 out of those 6, for the first case, for AB, 1 out of 6 by itself, which is 1 over 1 when you're dealing with in parallel, plus all of the 6 minus that 1 in series added in parallel with that other one, giving you the 5 over 1, or 1 over 5. I didn't explain it very well, but I think you can see what I'm getting at. So that is, if you wanted to find a common denominator, it's going to have to be, let's see, n minus 1 over n minus 1 plus 1 over n minus 1, which is going to give you, because the common denominator means it's both going to be over n minus 1, the top's going to be n plus 1, or n minus 1 plus 1, which is just n. Okay, anyway, in any case, this means when you flip it, when you take the inverse, because RP, remember, is the inverse of this, is going to be n minus 1 over n. That's always going to be less than 1. So it's always going to be less than 1. So that's always going to give you your smallest resistance. And you can see with the pattern that we've gone through here, you could do this as 2n and n minus 2. So that would be between A and C. You would have, if n equals 6, it would be, in fact, let's try it, do it next, we'll do it over here. If n equals 6, you would have 1 over 2 plus 1 over n minus 2. Okay, you with me? Because you've taken 2 off, and there. In which case this is going to have to be n minus 2 over 2 n minus 2 plus 1 over 1 over n minus 2. And I could be getting myself into a little bit of a mix-up here, but if we, let's just multiply this side by 2 as well to make it a common factor. It makes it a little bit easier. It's still multiplying by 1 to get that, in which case we've got n minus 2 plus 2, which is just n over 2 n minus 2. I don't know, this might be going nowhere, but that's what you get, and you can expand this out to be 2n minus 4. I don't know, does that help? Maybe we can substitute a number in and see what we get. If we substitute 1 into this, it's going to not work, because you need at least 2. You can't do it with 2, you need at least 3 in this. So 3 over 2 times 1, which is 3 minus 2, is 2. What if it's 4? 4 over 2 times 2 is 4 is 1. 5 over 2 times 2 times 3, so 5 over 6. It's always going to be just slightly over. But the maximum for the general case, let's see if we can do this right, is always going to be n minus n over 2. Okay, we're getting a little bit crazy here, but it's going to be n minus half of n, or 1 over n minus half of n, plus 1 over n minus half of n. It has to be, because this is when you're in the halfway case. And you could write this another way. It's just going n minus n over 2 is just n over 2. Let's write that as n over 2, and this is equivalent to let me see, getting myself muddled at the end of the day here, but if you do 1 divided by half, that's equal to 2, so you're multiplying that one by the top. So this one's going to be 2 over n. 2 over n plus 2 over n, which gives you 4 over n. And that means Rp is going to be equal to n over 4. So for any case where n is greater than 4, that's always going to be the largest, perhaps. I don't know. Okay, gone way too far. In any case, you should be able to see that for the circle one, it's going to be of resistance R, for the whole circle resistance. And this is getting back to the final, here we go, the final one over here, has resistance R ohms. R over 2, where here's our circle, where we're measuring the resistance between those 2 points, is going to be the maximum resistance. So we'll have R over 2 there, and we'll have R over 2 there, and we can add those by taking the inverses. So 2 over R plus 2 over R equals 1 over Rp, and so that's 4 over R, which means it'll go to R over 4 is the resistance in parallel. So let's go back up and see if that helps us down there. What will be the maximum resistance between any 2 points? Yep, it's just going to be R over 4. Whew, fantastic, eh? Yeah, I don't know how well that helps you, but the process certainly should.